Good morning, students. Today we'll discuss the derived gates. There are three types of gates. One is basic gates, universal gates and derived gates. What are the basic gates? And or not. And or not. These are the basic gates. What are the universal gates? Nand and NOR. These two are called universal gates. Then what are the derived gates? There are two gates, derived gates, that is Xor Gate, Xor Gate. So there are two derived gates, that means that these gates are derived from OR gate. These gates are derived from OR gate. First we'll discuss the XOR gate. XOR is nothing but exclusive OR. Exclusive OR. It is denoted with a plus with a circle. Plus with a circle. The plus will be written inside the bubble, that is called as exclusive OR. So we know that AND gate, OR gate, NAND gate, NOR gate, XOR, XNOR, all are binary gates. That means minimum two inputs. Minimum two inputs required. When we require minimum two inputs, this also exclusive OR, it takes two or more inputs, two or more input signals to produce single output signal. Single output signal. When the output is true. We'll see first the circuit diagram. This is a circuit. You know how to write the OR gate, right? So this is your OR gate. There are two input signals. One more circle, curved line in front of that gives you XOR gate. If A, B gives you within the XOR gate, then you will get the result as A plus within the circle B. Similarly, we can write two or more input signals also. This is your 3 input variable circuit, that is in the XOR gate. A plus B plus with a circle C. So, how you will get the output of this? So, if it is a 2 variable, how many input possibilities you will get? 4 input possibilities, that is 0, 0, 1, 1. 0, 1, 0, 1. This is your input possibilities. What is the output you are expecting? A plus of B. How we can write the output? The output is depending on number of ones in the input. Number of ones in the input. How many number of ones are there? There is no. Hence it is even. Here it is 1 is there. This is odd. Here also odd. Here 2 ones are there. That is even. The output is always depending on the number of ones in the input. If the number of ones are odd. If the number of ones are odd, then the output is true. Otherwise, the output is 0. Output is 1 if the number of ones number of ones is odd. Number of ones is odd. Otherwise 0. That means false. Did you got it? Here even. So only these two cases we have odd number of ones, hence it is 1. You know that this is a 2 input variable, this is a 3 input variable. We'll see how to write the truth table for 3 variables. Sorry. A, B, C. A plus R, B plus R, C. Okay. 0, 0, 0, 0. 1, 1, 1, 1. Here 2 zeros, 2 ones, 2 zeros, 2 ones. 0, 1, 0, 1, 0, 1, 0, 1. Find the number of odd numbers and even numbers. Can I rub here for a minute? Then I'll write you once again. This is even number. This is odd number. Odd number. This is even number. This is even number. Sorry, this is odd number. This is even number. This is even number. This is odd number. Wherever the odd is there. So here it is 1. Here it is 1, here it is 1, and here it is 1. Please notice here only one number is there. Here 1 is there, here 1 is there, here 3 is there. 3 is also odd number. So wherever the even is there, it is false. It is false. Hope you understood. Yes. This is your exclusive OR. It is an extended version of OR gate. It is an extended version of OR gate. It takes 2 or more input signal to produce a single output. Output is 1 if the number of ones is odd. If the number of ones odd in input. Otherwise, the output is 0. See here odd numbers are there, hence it is 1. Here also odd numbers are there, hence it is 1. Hope you understood. So we'll continue in the XOR. So XNOR. See, remember XNOR. XNOR is a complement of XOR gate. It is a complement of XOR gate. Do you know how to write the complement for this? Just A plus of B complement the result. Opposite of the opposite result. That is even number of ones you will get the result as 0. Odd number of ones you will get the result as even number of ones you will get the result as true. Odd number of ones will get the result as 0. Then here how we will get the 0, it will become 1. This will become 0. Just opposite sign what we got in the previous one in the XOR gate, that we are getting complementation of that is called as XNOR gate. Wherever the symbol N, the letter N is there, means we are complementing the result. We are complementing the result. What do you mean by XNOR gate? It is an exclusive NOR gate. It is an exclusive NOR gate. Do you remember how to write the NOR gate symbol? Similarly, here also we can write the NOR gate symbol. Output is 1 if the number of ones are even. If the number of ones are even, then the output is 1. Otherwise, the output is 0. The same circuit diagram, bubble in front of the output. A plus or B complement the result. Similarly, write for 3 variables also. A plus or B plus or C complement A, B, C. See, just now I mentioned the result. Output is 1 if the even number of ones are there. Even number of ones are there. If it is odd, it is 0. It is 0. Note, XOR gate is complement of XOR gate. XNOR gate is complement of XOR gate. XOR gate. Then how we can write this one? A plus B plus complement it. Here it is even number are there. Here it is odd number. Here it is odd number. Here it is even number. Here it is odd number. Here it is even number. Here it is even number. Here it is odd number. Wherever the word even is there, wherever the word even is there, output is 1. Output is 1. Otherwise, the output is 0. This is your XNOR gate. XNOR gate is nothing but exclusive NOR gate. Exclusive NOR gate. It takes 2 or more input signal to produce only one output. That output is 1. That means true if the number of ones is even in the input. Number of ones is even in the input. In the earlier one, odd. Now it is even. Just a single word. It is easy to remember the definition. In the XOR, odd number of 1. In the XNOR, even number of ones. And remember, XNOR is a complement of XOR gate. XOR gate. How to write the XOR? Plus within the circle, that complementation gives you XNOR. Complementation gives you XNOR. Hope you understood. So this is about your gates. There are 3 types of gates: basic gates, universal gates and derived gates. Basic gates are AND gate, OR gate, NOT gate. Universal gates are NAND gate, NOR gate. Then derived gates are XOR gate and XNOR gate. Okay. So once again we'll revise the XOR and XNOR. XNOR is a complement of XOR. XNOR is a complement of XOR. In XOR, odd number of ones gives you true result. In XNOR, even number of ones gives you true result. Okay. So this is your gates. So this one, whatever we discussed now, gates and gates explanation of types gives you very important for 4 marks. It may be possible for 1 mark question and it is possible for 3 marks question. First one is, what do you mean by logic gate? It is the first 1 mark question possible. Then, what are the types of gates? Or give the types of each one. What are the basic gates? That is also possible for 1 mark. What are the universal gates? Then what are the derived gates? What are the basic gates? AND gate, OR gate, NOT gate. These are the basic gates. What are the universal gates? NAND gate and NOR gate. These are the universal gates. Then what are the derived gates? One is Xor Gate, another one is XNOR Gate. Please remember, this complete diagram gives you 1 mark questions as well as 3 mark questions. AND gate, what is the symbol of AND gate? Dot is a symbol of AND gate. It performs what? Logical multiplication. Logical multiplication and performs logical multiplication. What is the symbol of this? This is the symbol of your AND gate. A, B, A into B. 1 into 1. Then only the result is 1 in the AND gate. That means all possible inputs are true. Then only the result is true. Otherwise the result is false. What is the symbol of OR gate? Plus is a symbol of your OR gate. It also takes 2 input symbols. 2 input symbols. A, B, A plus B. It is logical addition. Logical addition. 0 plus 0 only gives you the result 0. That means all input possibles are 0. Then only the output is 0. Otherwise the result is true. You can write one more way. Any one of the input symbol is true. Then we will get the result as true. Otherwise the result is 0. It is denoted with the overbar, that is called as NOT gate. This is a logic diagram for your NOT gate. If you give A, you will get the result as A bar. This gives you logical complementation. Logical complementation. 0 gives you the result 1, 1 gives you the result 0. It is also called as inverter gate. Inverter gate. What is the another name of NOT gate? Or which gate is called as NOT gate? Any one of that is an important for 1 mark, along with a truth table is important for 3 marks. Then come to your NAND gate. It is a combination of NOT gate plus AND gate. That means AND result complementation gives you NAND gate. A, B, it performs AND here. Before that complementation is there, that gives you NAND result. See, opposite of this. If inputs are 1, then you will get the result as 0. Output is 0 when all the input possibles are 1. All the input possibles are 1. That is about your NAND gate. The NOR gate, it is a combination of OR gate with the NOT gate. First write the OR gate symbol. A, B. Before that put the complementation. That gives you NOR gate. If all the possible inputs are 0, then we will get the output as 1. That is your NOR gate. Opposite of the result you will get over here. Here 0, complementation of 0 will get as 1. Here it is 1, the complementation of result you will get as 0. That is the use of here. See, notice over here, here n is there, here n is there, hence the bubble is there. Here also n is there, hence the bubble is there. Here n is not there, there is no bubble. Then come to your XOR gate. It is an extended version of your OR gate, hence one more curve line is there in the diagram. It is A plus of B. That in the circle you need to mention. When odd number of ones gives you the result as true. In the possible inputs, odd number of ones are there means you will get the result as true. Even number of ones gets you result as true. The circuit diagram, same circuit diagram with the n is there, hence the bubble should come. A plus of B complementation. Except the NOT gate. Except the NOT gate. All the gates takes minimum 2 or more inputs. 2 or more inputs. All the gates. All the gates takes 2 or more input except the NOT gate. NOT gate will takes only 1 input. Hence, a gate is a electronic circuit. Electronic circuit, that is a digital circuit, takes 1 or more input to produce single output. Single output. Except the NOT gate takes, all gates takes what? 2 or more. Definition you got. AND gate takes 2 or more input signals to produce a single output. This is a common for every definitions. But you need to define the output. This is the output definition. If all possibles are 1, you will get the result as 1. Otherwise 0. If all the input possibles are 0, you will get the result as 0. Otherwise 1. Opposite complements the result. Here all the inputs are 1, then you will get the result as 0. Otherwise 1. If all the inputs are 0, then you will get the result as 1. Otherwise 0. Here odd number of ones gives you the result 1. Otherwise 0. That means even gives you 0. Here even number of ones gives you the true result. Otherwise it is a false result. This is, each one is important, 1 mark as well as 3 marks. If it is for 3 marks, definition, circuit diagram with a truth table, TT. Truth table you need to write. If they have mentioned specifically, write a truth table for 3 variable, then you need to write the 3 variable. Otherwise, take a common example as 2 variables. Okay. Hope you understood clearly with the logic gates. 3 types of logic gate: basic gates, universal gates and derived gates. Basic gates are AND gate, OR gate, NOT gate. Universal gates are NAND gate, NOR gate. Derived gates are XOR gate and XNOR gate. Okay. We'll continue in the next class. Boolean theorems. Thank you.